Like I said, this is we are going to be discussing trigonometry from right angle triangle perspective. So before we go to other trigonometries, we if we discuss right angle triangle, we have automatically discussed equilateral triangle or isosceles. It is only scaling that we are going to be leaving out, and we have another theorem for that. That is the sine rule and cosine rule. To my own idea, I think we practically designed the sine rule and cosine rule for scaling, because we can solve all our angles and all our sides using Sohcahtoa and Pythagoras theorem. We are good with this. To get the angles, we use Sohcahtoa, and to get the sides, we use Pythagoras theorem. We are fine. But for scaling, it is not possible. So we needed the mathematicians needed to devise a means to solve scaling. So they came up with another theorem, another rule, which is sine rule and cosine rule. We are going to discuss that later. But let's focus on this first. Now, let me please pay attention as I label this work. If I have A and B and C as my angles, definitely the the side facing the angle A is the small a. Please note that it is important. And you can give it something else, but it is better we identify it with that. So the angle facing the C here is, I mean, the side facing the C, which is this is a small c, and of course the one facing this one is your small b. How do we identify, how do we name this? Don't forget, when we have a right angle triangle, we definitely have of opposite, we have our adjacent, we have our hypotenuse. I tell my students most time we have opportunity to discuss this, is that hypotenuse is the longest side. Of course, really don't measure. We don't measure our work, so our line. So we cannot say this one is. Of course, it is obvious to say, but there was a question we did in SS2 on circle like that, and we hardly could see the difference between the opposite and the hypotenuse, because they are very close. Something very very tiny like this was the calculation, very tiny like this. Then we needed to identify our hypotenuse. Then we came up with, okay, instead of we saying it is the longest line that we cannot even figure out, we rather say it is a line that faces the right angle. So get your right angle and understand the fact that your hypotenuse is the side that faces the right angle. That means this one. So this is your hypotenuse. If you have been able to identify your hypotenuse, then opposite and adjacent will be easier. Let me explain how you identify opposite first. It depends on the angle you are looking for. If you are solving from this perspective, then this will be your opposite. If you are solving from this perspective, then this will be your opposite. So once you have been able to get your hypotenuse and you have been able to get your opposite, then the third one will definitely be adjacent. Yes, there is a need for us to discuss what I call from here, what I call sine, cosine, and tangent. This. So if I am working from this A, sine of A is, please pay attention to this, it's important you know this, is equal to opposite over hypotenuse. Please note this, opposite over hypotenuse. That is, opposite, that means if this is the angle A, then this will be its opposite. Opposite, that means A and your hypotenuse, that is B. So sine A from this picture is equal to A over B. Cos A, now this will be, we are still on A. If this is your opposite, definitely this will be your adjacent. That means we have our adjacent over hypotenuse. So our adjacent is C and our hypotenuse is B. Please note this. And our tangent our tan A will be opposite. That means opposite over adjacent. That means opposite. Please pay attention to this. Over adjacent. My student will say OPP over HPY, and ADJ over HPY. It's very funny the first time I heard it. Well, I use opposite over hypotenuse, opposite over adjacent. But when David would say OPP over ADJ, I'm like, wow, okay, that's good. So here we have our opposite, that is from here we have our opposite, that is our A, then and our adjacent, that is C. It is from this concept that they came up with the, if this is sine and we have opposite and hypotenuse here, and cos to be adjacent and hypotenuse here, that means this and this, and our tan, that is TOA, that is TOA, then they came together to bringing everything together. We have Sohcahtoa. That is what they call Sohcahtoa generally. So bear that in mind. Get the spelling. It is Sohcahtoa. 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 This is Sohcahtoa. So once you have this Sohcahtoa, you definitely can work around these things to make it work. This is the introduction. Yes, we can as well solve from this end too. Solve from this end. So if we are solving from C, our sine C, then this will be opposite. Don't forget, this will be opposite. That is opposite over hypotenuse. That is B. I know opposite over hypotenuse. And my cos C now, that is my adjacent over hypotenuse. That is, my adjacent is, if this is opposite, then this will be my adjacent. That is A over hypotenuse. That is B. And so our tangent, tan C, will be, it is opposite over adjacent. That means opposite, using this, opposite over adjacent. That is C over A. This is what, and if, like I said the other time, you can have equilateral triangle, then you take you from equilateral triangle you can get right angle triangle where you use this method. Then you, from isosceles triangle, you can bisect isosceles into two to have right angle triangle on two sides, two right angle triangles. Then you use this method. So with this, equilateral triangle is a yes, then isosceles triangle is also a yes. With the right angle triangle is of course a yes. So let's check some examples, then we proceed from there.